So in this chart, we'll talk about an example of a non-inertial reference frame, and that will be on the right here, the reference frame of a car that's accelerating. Before diving into that, let's go down to point 7 here, which says that um, one of the attributes of a force is that it must have some kind of an agent. And if we can't identify such an agent, well, then there's no force. And it's relatively straightforward to identify the agents for contact forces. The long-range forces, or non-contact forces, are somewhat more subtle. So in the top left side here, we have a situation with a car going at constant velocity. That means it's going at constant speed in a straight line. And let's say that there's a mass m sitting on the level floor of the car, and that the floor of the car is frictionless. And that the car is, as I say, going in a constant direction, constant speed, in other words, constant velocity. Well, in that case, m will not slide. And if we think of Newton's first law, that an object will be in equilibrium if and only if the net force is equal to zero. Net force is equal to zero if and only if the acceleration is zero. That's true in this reference frame for this mass m. There are forces acting on the mass m. There is the weight of the mass m. That's the agent for that force is the Earth pulling the mass m down, and then there is the normal force of the floor of the car pushing up, counterbalancing the weight of the object, and the agent for that latter normal force is the floor of the car. The sum of the forces is zero, and by Newton's first law, it should not be accelerating, and indeed it isn't. It's going at constant velocity. However, when we go to the second scenario, where the mass now is sitting on the car floor as it was before, and the car is now accelerating in the forward direction, in the frame of the car, the mass is accelerating. In fact, it's accelerating towards the seated passenger, towards the back of the car. It's accelerating despite the fact that the net force is zero. There are no new forces acting on the car in this non-inertial reference frame than there were in the inertial reference frame. And that means that Newton's first law is not true. Despite the fact that the net force is zero, the mass m has a non-zero acceleration towards the rear of the car. Therefore, this reference frame does not meet Newton's first law, and therefore it's not an inertial reference frame. Now, from the point of a person standing on the street watching this car accelerate, they will observe this mass m going at whatever velocity it was going before the car started to accelerate. If the car was at rest and it's at a red light, for example, and then the guy steps on the accelerator to start the car accelerating to the rightward direction, then the mass m will simply remain at rest, and the person observing from the street who is in an inertial reference frame will conclude from Newton's first law that there is a consistency between the lack of acceleration of m and the net force being zero. Okay, so going back down to number 7, we've talked about the fact that a force has to have an agent, um, and that was one of the arguments we used to argue that this couldn't be an inertial reference frame here, this one on the right. And then that the force exists at a point of contact if it's a contact force, or if it's a long range of non-contact forces, we can still identify the agent. And the last thing is that the force um, due is due to current interactions, not past interactions. And so, for example, if you throw a ball, um, while you're throwing it, there's the force of your hand on the ball. But once the ball leaves your hand, um, the force of your hand is not there anymore, and um, its only function was to impart a velocity to the ball. Once it leaves your hand, your hand um, is in the past and not a factor anymore.